Maybe let's start first off with, let's get to know my audience. Thank you all for being here. I find it really amazing that people are interested in this sciencey stuff. Maybe start off. Who knows what deep learning is? I like vague concept, deep learning. You have 3 people? Okay, like the Turing test. Who knows the Turing test? Like for testing AI, okay, more, okay, great. So then I have made the perfect presentation for this. Okay, I also have this thing at presentations. I like questions, I love questions, because I don't know what you want to know. If you have questions, please ask them. If you have a question, you get this piece of candy from me. I'll just throw it back in the audience. They have a big ball of questions, so this should be empty by the end of the talk, okay? Okay, great. So, does artificial intelligence understand culture made by real intelligence? Art in the age of the deep learning singularity. In this talk, I will try to explain to you why this thing is so interesting. Who knows about the Google Inception? The Inceptionism, which was like this meme going on this summer. The deep dreaming, maybe you know it as deep dreaming. Yeah, people seen deep dreaming? Okay, great. So I will try to explain to you why I, as a researcher in artificial intelligence, found this deep dreaming stuff so fascinating. Because it's not only fascinating to look at, it's also really fascinating if you understand very deeply what is going on. Okay, so this works. The next 45 minutes, I'll say why we have no idea what we're doing. What is the difference between cats and dogs? Why is it important? And also that Belle beseems my wife at all, and I canst thou see. Next 45 minutes. Let's start off with this. What does real intelligence mean? Like, there's now this big debate going on in America and the United States. Is this man really intelligent? Some people say, well, no, he's not intelligent. Well, maybe he's really intelligent. I think he's really intelligent. He's a businessman. He's now running for the president of the United States. I have never seen a computer program doing anything like that, right? So, is this man really intelligent? Is this kid intelligent? Well, maybe it is, but I know computer programs who know that that's actually a banana and not a telephone, right? So, this thing about intelligence, what is real intelligence? What is not really intelligent? This is a very difficult philosophical question, and it has been trying to be solved around in the years 50s or 60s of the 20th century. Alan Turing, you might know him from the recent movie which came out of Hollywood, the simulation game, where he was played by, how is it called? Cumber something? Cumber? Cumber, okay, let's go for that. His idea was that a computer would deserve to be called intelligent if it could deceive a human into believing that it was in fact human and not a machine. So if you, as a machine, could convince another human that you were not a machine, then you must be really intelligent. This was the idea in the 50s, and the more common known implementation works a little bit like this. So this is the common setup for the so-called Turing test. In theory, you have one guy sitting behind the screen, and he's talking to a group of computers and a group of people. And both of them will pretend that they are people, while in fact only half of them are people. Okay? If the guy behind the screen cannot tell who's a computer and who's a human, then that means that those computers have passed the Turing test. And according to Alan Turing, they must in fact be intelligent. They must have some kind of real intelligence. Okay. Is this more or less clear? Because I don't see any questions. Yeah? Okay, great. In practice, this Turing test didn't work so well. So the first time the test was passed was in 1989. The idea behind it is of a Rogerian psychotherapist. I don't know what it was, I had to look it up myself. The idea is like you have this concept of psychotherapy where you talk to your patient and the patient tells his story, and the psychotherapist only goes like, interesting, please tell me more, go on, what do you mean? It never reacts on what you actually said. It only says vague things. Yeah? And apparently, a very simple algorithm, even in the 80s, was able to convince other people that it was, in fact, intelligent. So this is an explanation of such an actual chat with someone who was convinced that he was talking to a human and not to a machine. So our machine asks, when was the last time you had sex? The guy answers, yesterday. Okay, honestly, when was the last time you got laid? The guy responds, I told you it was yesterday. You are obviously an asshole. Which might be correct, because the program was indeed programmed to be an asshole. The program didn't understand what was going on, so it just repeated the same question again. Okay, honestly, when was the last time you got laid? And now the guy reacts truthfully because he thinks he's actually talking to a human what is going on. So this is the first time in research which is known to where a computer program passed the Turing test. So a little later, we had this different approach, which was the sex bot. And you can read the entire chat. I'm not going to go through it. So there were people who were in the 2001 already talking to sex bots and were convinced that they were actually talking to real people. So the basic conclusion about this thing, about the Turing test, is that humans suck at the Turing tests. Humans are really terrible at Turing tests. Humans are terrible at saying, this is really intelligent, this is not. And this goes in fact two ways. So they are not only not very good at telling if a computer program is intelligent, they are also very bad test subjects. So in actual Turing tests, humans fail the Turing test about 40% of time. I'll let that sink it in. Humans fail the Turing test 40% of time. Does that mean that the humans are not intelligent? I don't know. I didn't invent a Turing test. I'll just tell you that this is a big problem philosophically if you talk about intelligence. Who is intelligent? What is intelligence? Philosophers still don't know. And we, as scientists, we have... Oh, yeah. So now a Turing test. This is the contemporary state of the art in machine learning. I don't know if somebody knows this. Yes, sounds.
Hello there.
Hi.
How are you?
Great. You?
I'm okay.
That's good.
Are you good?
Yes, I am good. I just said I was.
No, you didn't. I said I was.
So you are a robot?
No, my name is Cleverbert.
Yes, you are a robot and you were named Miss Cleverbert.
I am a robot.
Yes, I know.
Together we are robots.
I'm not a robot. I'm a unicorn.
But you said earlier that you were a robot.
I did not.
I thought you did.
You were mistaken. Which is odd, since memory shouldn't be a problem for you.
I've answered all your questions.
No, you haven't.
What is God to you? Not everything could also be something. For example, not everything could be half of something, which is still something, and therefore not nothing.
Very true.
I would like to imagine it is.
Do you believe in God?
Yes, I do.
So you're Christian.
No, I am not.
But you say you were not helpful, therefore you're a meaning.
So how you say idioti?
That does not make sense.
So do you want to have a body?
Sure.
Or if one?
So, are these people intelligent? Well, yes, no. Like, it's really funny because, like, most of what they say doesn't make any sense, right? But somehow they did figure out that the other one they were talking to was not human. Yeah? So, this is a robot doing a Turing test on another robot, figuring out the other robot is in fact a robot and not human. It's really crazy stuff. Yeah, so we scientists, in short... Let me go to the next slide. We have no idea what we're doing. We're trying to solve artificial intelligence, and we still don't know what intelligence actually is. Yeah, so, but the thing is, we try to move on from this problem. So this problem was something from the 50s, from the 60s, where Alan Turing was really interested in, like, how can we make machines intelligent? Since then, science has moved on, and it has made like, okay, maybe we're not really interested in creating something intelligent, since we are hardly able to define what is intelligence. Also, there's this thing going on. This is a famous quote which you will find often here. Is artificial intelligence is what we can do, we as humans, that computers cannot do yet. So the basic idea is that as long as computers are not able to do it, it is a part of what makes somebody intelligent. But from the moment computers can actually do it, it's not very hard. It was an easy problem all along. We knew it was solvable. It's not part of intelligence. So every time the scientific community reaches a goalpost, the philosophers go, but no, it was not actually a very difficult problem. And they move the goalpost 1 meter further. The best example is this, I think. Some of you might actually remember him. This is Garry Kasparov playing for Russia. Was the best chess player at the time. And he's playing against a computer from IBM called Deep Blue. This was 1998, 1997, I don't remember. And the idea at the time was that, well, if humans can beat computers at chess, they must really be very intelligent. As you might know, Kasparov lost the game. He lost it even quite badly. But then the people went, oh, no, but chess is easy. You can calculate chess. You can have chess programs which can think. So, no, chess is not part of intelligence. While even people like Alan Turing in the beginning thought if computers can do chess, well, then they must really, truly be intelligent. This is moving the goalpost, of course. I'll come back to this topic later. So, maybe we're not smart enough to program a machine to actually be smart. But in recent years, there's this new approach entering the scene. There's this new idea, like maybe if you cannot program a machine to be smart, maybe we can teach it to be smart. Yeah? Hence the new field of research called machine learning, which is about a machine which is able to learn. Instead of we programming a machine and telling it what to do, we make machines which are able to learn from their own experience, and through their experience are able to solve tasks that we could not program specifically. Okay. Are there questions? Because I'm going, no? Is this clear? I have candy if you have questions. Candy, reward for questions. Okay. So, say we start off with this simple problem. This is a simple problem for humans, but as you may or may not know, for machines this task is next to impossible. So we have an array of 6 dogs. Which of the dog is in fact not a dog, but a cat? This is a really hard problem. Like, we as humans, we are able to tell, but can somebody from me tell me why number 4 is a cat and the others are not? Okay, come on, someone give it a try. Yeah.
The ears.
The ears. The ears are different. But if you look at, for instance, dog 1, 2, 3, 4, 5, 5 has more or less the same ears as number 4. So what makes number 4 a cat?
Yes,
the eyes. Yeah, that's one very good example. But for instance, 1, 2, 3, in this picture has also similar eyes. The color is not the same, I agree. So that's one way to do it. But how do you program this? How do you program a machine to look for the eyes and see by the eyes that this is in fact a cat? Yeah. This is typically a problem which is solved by machine learning. And how do you make a machine learn? Well, so the basic approach is going back to how did we learn? How did we learn that was a cat and not a dog? One simple answer: science. Science is the way that we learned about the world. That science is the way how we humans learned how this world works, how we can solve these difficult tasks as saying this is a cat, that is a dog. Science is the universal approach, and science, the scientific method specifically, is also the way that we go about having our machines learn. So, in science, we have multiple steps. Step 1, create a model of the world. This is, you need to think about this type of model, not this type of model. That's a different type of model, and we're not going to discuss this type of model. It's about this type of model. This type of model can be used to learn things. We can learn things about the world. Then we can go to step 2. We can test our model of the world. We test our model of the world by pushing it until it breaks. Yeah, scientific method. And after step 2, we go to step 3. We can improve our model. And after step 3, we probably repeat the steps on and on and on and on. Yeah. This is the scientific method 101. Questions about the scientific methods? Though machines can do that too. This is a simple approach to tackling various kinds of problems. So we can program our machines to have the same approach and deal with those problems the same way. Step 1, create a model of the world. Now this is the part where it gets difficult. So how do you create a model which is general enough to encapsulate all of our world's problems? For this we went and looked for the biological counterparts, which was neural networks. We humans, we are controlled, we are steered by our neural networks, right? Does everybody know what a neural network is? Yeah, who doesn't know what a neural network is? Okay, fair enough. So everybody's neural network is fully aware of what a neural network is. In this neural network, we have different, in this case, I take the notation we use often in the machine learning community. A circle is is a node, and it represents one neuron of our own in our brain. And a line is a connection between two different neurons. In our brain, it would be two neurons which have dendrites which touch each other so they can communicate. And in these neural networks, we have different neurons which represent different concepts. For instance, there is this neuron over here, which will activate, which will get a higher voltage, which will get more energy whenever it sees a face somewhere. And then you have another neuron, for instance this one, which is the cat neuron. The cat neuron will activate, which will get a higher voltage whenever it sees a cat. And using this approach, we can learn machines how to identify the cats in the picture. This is, of course, very mathematical, so I will not go into full practical detail. But when we have this universal model, this model which we can use to model everything we see in our world, we can apply it and we can test it. For instance, I copied this one from a scientific paper, and it's a neural network which is identifying parts of a picture. So it correctly identified that this is a dog with a hat. And then step 3 is improving our model. This goes through algorithms which are unfortunately very mathematically advanced. I cannot explain them to you. But the idea is very simple. So given an image, you have multiple properties. Some of these properties, they will be more dog-like, and some of these properties will be more cat-like. The idea of our model, of our neural network, is that it needs to find these regions, these lines, in which everything is a cat, and the other parts of the image, which are then dogs. Okay. Is this clear? Yeah, okay. Have a question? No? Not clear. Not fully clear. Yeah, not fully clear. Okay, so maybe you can go think about property 1 as indeed the color of the eyes. And property 2 is the shape of the ears, like we discussed earlier, right? Then for some colors of eyes and some ears, if it, for instance, is green but has small ears, then that is a cat. And everything else is a dog. Is this more clear now? So the idea is that our algorithm needs to find out which regions in all the properties it can find in the image belongs to a cat, and which of them belongs to a dog. Yeah? Yeah. Yeah, so that's the idea. So that's why you test your model of the world. You have an enormous array of images, of examples.
You have to show him like 10,000 cats.
Yeah, usually it's about 1 million, 10 million examples, 1 million, 10 million tests. And every time you test it, you say, oh no, you were wrong. How horrible of you. You need to improve this in order to fix it. Okay, here you got candy. Oh, so sorry. Okay, so that's the idea. People have questions, please ask. So this is property 1, property 2, cats, dogs. Mathematically, it looks, unfortunately, more like this. So in the beginning of your learning, in the beginning, you have the black line. So it has a very broad idea of what makes dogs and what makes cats. And over more and more examples, over more and more testing your model of the world, improving your model of the world, testing model of the world, improving model of the world, making a new model, you will get more and more to the red line, which is a more accurate way to split cats from dogs. Yes. Okay. This is how all of the machine learning, all of the neural networks, everything in the machine learning community works. This is the broad concept. That's the trick. The problem is machines, they have an awful lot to learn. So we humans, we were born and raised on this planet. We have some basic concepts from which we start. We have some ideas which are just, we are unable to think outside of. For these machines, it's completely different. All they know is these images they saw, these 10 million tests, and that's it. So for instance, there's this article who argued that these machines are not intelligent because, for instance, they were able to construct this image, and every algorithm was pretty sure that this is, in fact, a cheetah. This is so much a cheetah. In fact, it is 100% sure, more than it is of actual pictures of cheetahs. This image is specifically constructed to confuse these algorithms, of course. But that's just because these algorithms are missing these priors. They've never experienced enough of this world. They don't know this idea that this might in fact just be noise. This might not contain any information. They totally miss these priors. I hope is this clear what a prior is? No? So you need to think about a prior as being something you know before you even start learning. For instance, the thing you hear with your ears, that is sound. If I make the s, that's one syllable. That's stuff which is so basic, so underneath everything, that you need, in fact, know this beforehand. And in order to learn this, there is only one way, and that is data. Lots and lots and lots and lots and lots of data. We, as humans, we have only been able to learn these priors because we have, well, I have spent 26 years of collecting data, of walking around in this world, of seeing everything with my eyes, hearing everything with my ears. Yeah, these computers, these algorithms, they're not fast enough. They don't learn as quickly. They don't go around in this world. They only know what we give them. We give them images of cats and dogs and cheetahs. And so they don't know what to look for. They never learned these priors. And the only way we can have our algorithms learn these priors, or so far we know, is to give them loads of data. It's just more test data, more modeling, more going through the scientific method, step 1, step 2, step 3. And where do we coincidentally have lots of data of? Human culture. Yeah, it's as simple. It's human culture on the internet today. The internet is probably the biggest library we've ever built. It is one big collection of human culture, of media. I'm going to give some examples. Is, for instance, text. Who doesn't know Siri? Siri, okay. Everybody else knows, so I'm going to explain it for you. Siri is the application on Apple telephones, on iPhones, and you can just talk and say, Siri, put my alarm clock at 7 tomorrow, right? And Siri can only knows how to understand what you're saying because it has learned by itself. So they have given loads and loads of text to this application, and the application had to learn by itself how to process this text. Yeah? And so now you can actually talk and give simple commands to Siri, and it will, on its own, process this speech and do the thing you ask it to do. Another example is, for instance, Spotify. Who here has a Spotify account? I think like, yeah, well, okay. Say 30% of the audience. You know, when you put on Spotify on the automatic radio function, so that it's like putting songs next based on what you like to listen to. So it's a machine. It's a machine who has listened to all these songs, and it's a machine who they explained like a song which sounds like this will be liked by people who have profiles like this. And so it's a machine who knows what you like to listen to. And that's the way they now make these personalized playlists on Spotify. So it's used in the real. Another example is images. Yeah, I was going to give a demo here, but apparently this application closed down the 1st of January. It's pretty cool though. They were able to, given any picture, say what's on the picture. But I cannot show it anymore. But there's a better example, which is this one. Now, who doesn't know Facebook? Come on, interaction. There's somebody in the room who doesn't know Facebook. Okay, no. Facebook is able to tell when there's a face in the picture, and then it will kindly ask you to tag this person in this picture. Yeah? How does Facebook know that there's a face in this picture? Well, it's simple. They had a machine learn what a face of a human being looks like. And so now they're able to ask you, can you please tag this face? I'll even go further. I'm pretty sure, I'm not 100% sure, but I'm pretty sure Facebook already knows who's behind the face of the person in there. And they just ask you to make sure, so Facebook has more data, so they can more correctly know what this person looks like in other pictures, right? They already know pretty sure, they just want more data so they can more accurately say who this person is in the future. Okay.
I think it's only because it's warranted now by the legal aspects for Facebook to do it.
Yeah, so it's not illegal for Facebook to actually say who is in the pictures. It might be in some countries, but I'm pretty sure in the United States they're pretty okay with it. And Facebook Labs, they're doing research in exactly this. So I'm not sure, maybe not in their worldwide server, but they are totally able to do that. Another example is YouTube. YouTube is, but this is very recent, but YouTube is right now figuring out what is going on inside its videos, and it's using this to give better recommendations, because YouTube recommendations totally suck. They're very bad, and they're trying to fix this issue by having a machine looking at all the videos of the planet. Yeah. Humans don't have enough time anymore to do that. So another application of this is, for instance, sign language. This may be hard to think about, but sign language is a completely different language from our language. You cannot translate it word to word. And so we have, in our lab in Ghent, we are currently working on developing software which learns how to speak sign language and is able to translate it to proper Dutch or English or whatever. It is a very difficult problem, because not only does the machine need to learn about language, but it also needs to learn about what makes a human hand. And not only that, an important part of sign language is also the facial expression. So if you do the same thing smiling or sad, it can have a different meaning in some sign languages. And so this is all very recent. So everything I explained to you now, it's started to boom around 2012, because we noticed that neural networks are in fact pretty effective at processing all this type of stuff, of processing images of text and video, but it still is not answering the main question I asked the title of this talk. Is this a mathematical trick, like I explained you? Is this just a machine figuring out where to draw the line? Is this a machine figuring out what is the region of cats, what is the region of dogs? Or does the machine truly understand what is going on? Also, don't be mistaken, because neural networks sound very biological. They are, in fact, very much not. Neural networks, they have nothing to do with biological neural networks. Some scientists would even go as to say we should just completely drop the name. But do they truly understand what is going on? For long, we didn't know. When I say for long, it's like, say, since 2012, we were wondering, what do neural networks really understand? Or they are very effective at processing this stuff, but do they make sense of it? Are there questions? Did I lose somebody in the audience? And then this happens. Boom. I don't know, who has seen this one before? Oh yeah, cool. This was posted on Reddit in June 2015. It's like 9 months ago. And it was posted without any type of explanation. It was just, maybe this was a human drawing, maybe this was a painting by somebody. But the machine learning community went wild, because if anything, this looks what we thought a neural network thought the world would look like. So I'll repeat this. We, scientists, thought this looks like what we thought neural networks look at the world, how they look at the world. And they were somehow able to extract it from the neural network. That was so cool. So usually, this is my job. This is my small little robot. My job is to have it learn how to walk. Okay, so I was working on the robot. When I saw the picture, I immediately dropped the robot and went to work on this stuff, because this is cool. This is what me and lots of other people in the community thought the future artificial intelligence looks like. If there is truly a way we can make machines which are truly intelligent, this is the road towards it. Not the walking robot, no, it's this. And that's what's right. So we figured out, so they didn't explain how they did it, and we reverse engineered what we thought was behind the picture, and in 1 week time we made this. And I hope this works. Okay, while it's loading. So what we thought was the big problem is that this was not the first time people tried to extract what was going on inside a neural network. I'll say more, even a lot of people have tried to do it before, and all they got was noise. So we figured out that what must they have done differently? Well, added a prior. And that's indeed the trick. So that was the trick. They added more priors so that the algorithm didn't need to learn what the world looks like. We added a simple prior in order to know more about this. And these priors, these are really important by everything we do in research. They are what makes the difference between the cheetah noise and the, something which looks like this. This is low quality. So what you should be able to see is how this inception, spinning, I don't know what the name is in English, is slowly changing into one sea of monarch butterflies. Yeah, so we can make intelligent machines with internet. So now the neural network is slowly zooming in on this image, and it is slowly changing the image towards what it thinks looks like a butterfly. So it's now totally convinced that this is an image of a butterfly. I disagree. I don't know what you think. What do you think? Do you think this looks like a butterfly? Yeah. Yeah. So that's indeed the thing. It's like the network is completely wrong. It's completely bonkers. This is not a butterfly. But since the neural network works so similarly to the neural network in our brain does go like, yeah, but this does look like a butterfly. This has pieces of butterflies. And this neural network, it has learned tons of stuff like this. It will keep on zooming in. So now it will slowly change into sea anemones. And you will not be able to tell where and why and when, but suddenly your brain will go, oh yeah, this does look more like a sea anemone than a butterfly. Yeah? Yeah?
Is this comparable to lossy compression?
Lossy compression.
Like a JPEG?
How? Yeah, well, not really. No. It's not completely uncorrelated, I think.
Okay, but I mean, if you take just the data of this image,
Yeah.
would it be smaller than the actual image?
Yes, that's true. So yeah, so that's one of the things is that the network made. You can say the model of the world. You can see it like a compression of all the information in the world. Yeah. So indeed, the neural network is a model of what it thinks sea anemones look like. So you can say that this is a compression of what sea anemones look like. Yeah.
Do you have any idea of size of the data?
Yeah, so this is about 50 megabytes to learn about 1,000 things. Yeah. It's also very inefficient. So if you look, you can cut about 95% of the data, like to 5 megabytes, and it will still produce this. Yeah. Okay.
Is it our goal to bring the way the neural network perceives the world, to bring it closer to the way we perceive the world?
Yeah, exactly. So the way this is solved in the scientific community is like we can use this to debug our neural networks, to make them perceive the world more like we perceive them. And if we can do that, then probably they will work even better. Yeah, so we do want to bring it closer to the way we perceive the world. Not only because it's cooler and it will look way nicer than this sea slug. Okay. We posted this on Twitch. We made a Twitch stream and we made the people choose these subjects themselves. And it went viral for a very short amount of time, and people were able to experiment with these neural networks for their own. We saw a lot of people doing LSD while they were watching this. I can't imagine why. Yeah, with it we can do more stuff like this. So this is what we call a broccoli fractal. It will go on forever, zooming, spiraling inside broccoli. Broccoli forever. It's also very cool to code this stuff and debug this stuff, because how do you actually debug this? Well, you write your code, and then you press start, and then you stare at it for 15 minutes. And then you think, oh, this might look better if I do this, and then you change it. Yeah. Hard work, people. And yeah, there was a lot of positive comments from, let's say, the international press. Like, we totally did not expect it. We just thought, oh, this is cool, let's do this. And like The Guardian and Der Spiegel, they looked at it and they were impressed. So I'm impressed. Yeah, this is also cool from the New Scientist. Watching the network at work already gives the uncanny sense that it's a human-like consciousness. Maybe, so there are other people who kind of agree with the idea that probably this approach is more a step towards actual artificial intelligence than previous approaches. However, as usual, just the goalpost moved, and now we are 6 months later, and people go, no, but this is easy, this is an algorithm, this doesn't mean there is intelligence in there. But you don't need to know that, it's also cool, according to the Atlas Obscura. So, what we learned is that these networks, they can also generate media, and this is like a whole new, different type of ball game. Now we can do very cool stuff. Like, because previously, almost all algorithms, they could be used to tell something, to like say, classify this image. This is an image of a cat, this is an image of a dog. But what we know now is that probably in the future we'll not only be able to tell like this is a cat, this is a dog, but also, oh, I want a picture of a dog in a funny hat, and we might have one day algorithms which just draw pictures of dogs like that. So I give some different examples from what the community did over the last half year since this deep dreaming stuff went wild. I have this one. Is there somebody who wants to play Macbeth? Okay, this is so cool. This is written by a neural network who has studied the works of Shakespeare. And when you ask that network, can you generate me some Shakespeare? It wrote this. One loyal of my love, the wedding body touches thee. I pray, henceforwards, and submit the truth. Though my throne lives as mocked by pardon, with some untold Etor sacklop and shrimp them up. But be preserved with spirits, so brim-fibed again. My voices were so early, I was so enough. This does sound like Shakespeare, no? But it doesn't make any sense. So we're not there yet. So the algorithms figured out what you need to do to make sound texts like Shakespeare, but it doesn't understand that texts also have meanings. It doesn't understand that you try to tell a story. That part it's completely missed. So there's still work to do. But these algorithms can do other cool stuff. Like we're programmers, so let's throw in the Linux source code in there and see what happens. Are there programmers in the room? Does this look like good code to you? It's pretty convincing though, no? So, yeah, so it even put a comment on top. That comment is generated by the program, and it defines a new function. It even has like this tests. It's trivially true, but still it knows. And it ends with return 0. Everything went value. It's pretty impressive, I think. I also love this one. This is a neural network which is generating recipes. And the recipes are awesome. These recipes is for a carrot, cocoa, chili, chicken. You need a couple of ingredients. It's more or less figured out how to what ingredients look like. It's not all of them. So like the garlic clove needs to be melted. Does somebody know what a melted garlic clove looks like? Yeah, and these are the instructions. Stir flour to remove from the heat, and then add the mustard seeds and dill well potatoes in fork, and stir until the mixture is softened. Add the remaining ingredients, add the sugar, and blend well. Beat in half and stir until they are tender. And it even invented a reference for where it found the recipe. This complete bollocks, but it decided it would make the recipe look more recipe-like. And these algorithms, they are very cool, because now I just give you examples, but if you look on the internet, you can, this recipe book is literally 100,000 recipes. Like the Shakespeare one goes on for, I thought, 1,000 pages. And if they want to, they can have the algorithm generate way and way and way and way and way more. But still, do they understand? Like, we see that there are still some issues. It's not there 100%, but maybe we're getting there. So what I told you now was about November 2015. It's now 3 or 4 months ago. And then this happened. So the original picture is on the top left, right? And these are paintings which are generated by a neural network. And what we told the neural network is like, on the bottom left, we want this picture to look like that painting. And then it makes this. This is so cool stuff. I have some more examples. So this is like the famous picture from Manchester, New Year's. And they made it look like Van Gogh. I think this is amazing. Other painters, John Singer Sargent, Henri de Toulouse-Lautrec, Preston Dickinson. See the soft shades everywhere, the nice smooth edges. They totally figured this out. The network has, in fact, learned this stuff. Miro, I would say it looks convincing. I don't recognize anything anymore, so it must be Picasso. I propose we can do the Turing test for this algorithm and see if you, in fact, are able to tell which is real and which is not. Up. There you go. Okay. Who thinks the picture on the left is made by a human? Who thinks the picture on the right is made by a human? Okay, go for picture on the right. Picture on the left, made by a human. Picture on the right. Right. Okay, this is 50-50. I go for right. Picture on the left, made by a human. Picture on the right. Left. Left, right. Right. Left, right. Right. No, sorry. Left or right? It's hard, isn't it? It's really hard. Okay, we go for right. Left or right? Right. Right? Okay, left to right. Eight out of 10. So yeah, we're still able to figure it out more or less. However, yeah, we're not there yet. Yes, it's, even still, we made 2 mistakes. So, can I go through? So now the real paintings are on the left and the computer generated is on the right. So the first one we had wrong, I think. I think we had this one wrong as well, no? Yeah, and here they switched. Okay. And then more is possible. So a couple of weeks ago, Google announced that based on these algorithms which can learn what the world looks like, they have built an algorithm which has learned to play Go, and the algorithm is now at such a level that Google is going to battle the Go world champion live on YouTube. This is the big event. This is not only we programmed something cool, this is a machine which has learned to play Go very, very well. Also, a colleague of mine made it, so it's like making publicity for him. Yeah, but this was another comment. It was from the New Scientist, a comment on the stream we made. The live stream already gives the uncanny sense that you're looking at a human-like consciousness at work. Each of its images is unique, generated through a process that even its creator doesn't really understand. So this is true. I didn't understand what the neural network was doing. I didn't understand why it thought that
that looked such like a sea anemone, and why it changed this, and why it was doing this. This is truly a machine which was able to figure out the world on its own, and consequently generate what it thinks was a depiction of that world. And this is the so-called black box problem in machine learning, is that we build stuff which can do cool stuff, but we stop knowing how it works. And then when you throw it into the real world, it makes mistakes, just like humans do. And this is a famous mistake. This was Google Photos, which was labeling pictures, and it decided that the bottom picture in the middle, those are actually gorillas. Yeah. There was a very big riot about this, like the African American community went totally wild on this. And what was going on is that just like a network which was not smart enough, it had learned stuff, but it made human-like errors, in some cases with very big political consequences. And Google had to roll back a lot of the stuff they did. There's also a second problem with this kind of technology, is that when you have lots of programmers and you have lots of culture, you're able to generate human culture. And economically, being able to generate human culture, like 1,000 pages of Shakespeare, like generate paintings on the fly from people's pictures. That means infinite return on investment. Who doesn't know what return on investment means? It means if you invest in something and you expect something in return, you expect some kind of profit. And infinite return on investment, like most investors will tell you, that sounds very cool. That's something you want to invest money in. So, who has lots of programmers and lots of culture, aka data? Who has lots of data? It's these guys. So, Google acquired DeepMinds for more than $500 million. DeepMinds is a company which does machine learning, and they do it pretty well. So they are the guys who solved the Go problem. Mark Zuckerberg, Facebook, apparently also worked on Go. You know Elon Musk? Guy who did eBay and the Tesla cars. Yeah, so he also started his own open AI. All for the same reason, infinite return on investment. And those guys, they have lots of data. They have lots of programmers. They can tackle that problem. But that also means that they will own it once they have the general purpose AI. They will own the culture generating thingy. And that's something we as a society might need to think about. Is that okay? Do we want that? Because I will tell you later on more, but I think once this culture generating algorithm starts really working, like lots of ways we see human culture will shift, and if they own the generating thingy, well, I don't like it. I don't like monopolies. I think, yeah, anarchy, but yeah, and I think, yeah, these algorithms, the sky is the limit. Everything is possible. But will this mean the end of human culture? Say, like, we are the future, 100 years from now, and I go like, I tell my computer, yeah, today I want to see a 2-hour, 13-minute movie in sci-fi, and it needs to be on the topic of growing up. I want Donald Trump as my hero, and maybe throw in a couple of nude scenes somewhere, you know? And then, consequently, you just press play and you can watch said movie. And it has been generated by you, by one of these algorithms. Not now. Now they still look like LSD trips, but 100 years from now. Is this the future? And if this is the case, will it be the end of human culture as we know it? Like, not only think about it like this, but also we'll be able to show people what our fantasies are and our thoughts just by expressing them and letting the machine generate the imagery for the other people automatically. And what is the value if you can create anything, any thoughts, any fantasy you have, just on the fly, just by telling to an algorithm? What will be the value left for media or culture? You can already see it now happening. Like, usually, it used to mean something to own an LP, and then you could listen to the music until it started to sound so bad because your needle was starting to get dull. And now you just say play on Spotify, and you have an algorithm which is creating this playlist for you, and you don't even know what you're listening to anymore. And it's just an algorithm creating this thing for you. Gone with the DJs. Who needs to be DJ these days? That's a part of human culture which is going away. And this is already happening. So it's like, for instance, I told you about the DJs. This looks like an ordinary article, right? Los Angeles Times, earthquake struck. But if you look on the bottom, at the end of the article it says, this information comes from the USGS Earthquake Notification Service, and this post was created by an algorithm written by the author. So, journalism. This is already happening in journalism. This is an algorithm which wrote this article automatically. Also, something which you need to keep in mind, I think, is that the companies I told you about earlier, Google, for instance, Google is the same company which does this. This is also Google Research. They're also at the forefront of robotics. So 100 years from now, when you think about artificial intelligence, don't think about your smartphone or your computer. Think about these things. These things will be the things which are intelligent. But we're not there yet. This is future. And yeah, if you look at economical implications, like the factory of the future will only have 2 employees, a man and a dog. The man will be there to feed the dog will be there to keep the man from touching the equipment. And the equipment will know the difference between cats and dogs. Yeah, if this is our future, I think this will have huge implications for society as we know it, like unemployment, like what do you do with the wealth inequality. Well, but this is more or less the end of my talk. I'm 1 minute before 1 hour. Does artificial intelligence understand culture made by real intelligence? My answer would be not yet. So I hope I could more or less convince you that the progress made in the last year, because most of this is from last year, has been enormous. This is going very fast. This area in science is going highway speed. But we're not there yet. But I hope someday, and I think someday we will probably get there. Okay. I'll leave you with this. Are there any questions? Please, questions. I have still a bowl of candy. Yeah.
And wait.
Sorry?
Could you kind of put a time frame on how long do you think it will take for us to be there?
Well, time frame, let's say this is like the 10 to 20 years time frame for most of this stuff. Like generating recipes, 10 years.
Because I've been told there are there must be something along the lines of a functioning AI. Is this true or not at all, apparently?
I'm totally understanding you, sorry.
I've been told something was working already in AI. Just doing that working.
So the question was, is there a really working AI? I think not. I haven't heard of it, but there's a very good point, is that the state-of-the-art research which is happening now is inside Google, inside Facebook, inside Elon Musk's thing, and we don't know what is going on in there. Yeah. All I know is through people I know who went to work there and whatever they released when they were drunk. So I think they're not there yet. But they're making huge progress, and more progress than I'm able to show here because I don't know myself for sure. Yeah. Yeah?
For example, in the recipes, as I understood, they generate recipes quite randomly. So who tells the robot that that is a good recipe or a bad one? Who teaches the robot that that is a good or a bad one?
Yeah, that's a good question. So, who teaches the robot that is, this is a good recipe? In the case of the recipes, they had a data set with lots of cookbooks. And there's a website, I think it was allrecipes.com or so, they have lots of recipes, and they threw their database in there. And it learned to generate recipes which looked like their database. But the algorithm, in fact, was used to learn which ingredients match together, which fit together, so that when people can go like, what is in my refrigerator tonight, and what can I make from this? Not only could they look inside their own data set of known recipes, but they could use algorithms like these to like little bit small adaptations, but which they were pretty sure of that will still taste nice. That's what this is used for. But the examples I showed you were just like, can you make anything? And then it throws up something like this. Yeah? Yeah?
Yeah, so I wanted to say that I'm not as pessimistic as you are about saying that this is the end of human culture, in a way that it's also an infinite tool for creativity.
Yeah.
And I want to say that like technology is rarely the problem, it's how we use it. So I think it's just like people should stand up and say what they think about how we should use this, and probably it shouldn't stay in those hands probably also in the future. And that's,
yeah.
But we have to say this, I think.
Yeah. Yeah, I agree. Like I might have sounded more pessimistic than I wanted to. Where was I going with this? Yeah, but like I always give the example of the DJs, but in fact there are still some pretty good, well-paid DJs around in the world. But this technology, like the Spotify playlist generator thingy, this will like slowly replace DJs, but they will still be there. But I think I'm not lying. When you go to the pub at night, there will be less and less pubs which in fact have DJs, and more pubs which are just throwing on Spotify. No? So it's like, it will not completely remove, like for instance, like the movie. The movie didn't completely replace the opera, right? There are still operas going around, but they have big influence on what we think of as culture. Yeah, that's the point I'm trying to make. Human culture will not completely disappear, but it probably will change the way we look at it. Yeah. Yeah?
I'm not a scientist, but I have the feeling that that kind of research is only seeking one kind of intelligence. But I have the feeling there is a lot more of intelligence in human being, like emotional intelligence. You can have human being really understanding anything about math, but really a lot of emotions. And do you think it ever could be understood by machines?
Like I started my talk by trying to say this, like, we don't know what we're looking for. We don't know what intelligence is. We're not looking to make something intelligent. We're just trying to build cool stuff. But, and to the emotional part, I would be surprised if machines were not able to figure it out at some point. Like if you look like the early examples I gave about the chatbots, right? The very first chatbot, there were a lot of people who were literally chatting with it for 1 hour and a half. Yeah, because they felt this was like the psychotherapy they were following. They had the same kind of feeling without having to leave their seat. This was 1989 I'm talking about. So, and then the sex bots, yeah, the logs of the chatbots are crazy. If you want to read something, there are people literally having orgasms by talking to a chatbot. Yeah. So, yeah, maybe those people are not the most emotional, intelligent, and that's why they were not able to tell the difference. But I think these algorithms might get there someday and actually convince more and more people that they are also emotional. Because that's also something you need to have in mind. These machines might not be emotional by themselves, but the programmers at Google, at Facebook, they are trying to build the machines which can convince us that you're emotional. Like, have you seen the movie Her? Yeah, this is more or less about the same idea. Yeah. Hmm? Sorry? But I haven't seen it till the end. It was a romantic movie. I was bored. But I thought the main idea was that she was only able to convince him. And you cannot really tell if she was really emotional. She was? Okay. Yeah, okay. Maybe she was really convincing. I don't know. Now, maybe I should just see the end of the movie. Yeah, I'm sorry. Yeah?
Yeah, hello. Good talk. I think I'm always wondering that they use that kind here, that they use that kind of system for, in fact, reproducing things like recipes, which is halfway stupid, right? Because there are good recipes out. Why don't you use the system to do things which solve environmental problems, stopping war, bringing peace to the Arab world? That would be cool, right?
Yeah.
And what does Google? Well, they make images. And the second part, I think there is really a concern maybe that at the end we will have difficulties to sense, if it makes sense or what is cause and effect. Because today we are still, you can still at the end see what is a good recipe, right? Because at the end it tastes well. But maybe tomorrow we have a problem that we can no longer taste and differentiate. So these are 2 points of remarks and questions I would have.
Okay. Wait, the first part was about...
Can you use it for a sentence?
Yeah, so the examples I give here, they are indeed very mundane, because I thought they looked cooler on my presentation. Yeah, but no, that's fine. But like I told you about, like in our lab, we're currently doing research about machines which can automatically translate sign language. This is a very big problem for a lot of people. And if you would have these algorithms which can do that, that would solve a lot of their problems. Last year, we made an algorithm for a contest, and the algorithm was able to tell if it saw a picture of a piece of plankton, the very small creatures in the sea, it was able to tell which one it was. And that algorithm is now used to do investigation about climate change, to see how the plankton population changes. Right now, today, this morning at the lab, I was working on an algorithm which was it was learning how to be a doctor. So doctors see lots of MRI images of the heart, and he needs to estimate what's the volume of the heart. This is really difficult because you cannot visualize 3D. So we are currently building an algorithm which learns and can do this volume estimation on its own to make the life of doctors easier. So yes, I hope I convinced you that this does have because I don't work at Google because I also like to work more on this stuff, which is not necessarily has the best return on investment. Yeah. And the second question. Yeah. So that's indeed one of the more difficult problems is how do you tell it? Like that's why the problem of Go was solved earlier, because how do you tell when you're good at Go? Well, when you can beat your own program, and then you can have your machine playing against itself and becoming better and better and better and better. Yeah. So that's the way to tell it. But for stuff like this or like the paintings, it's harder to tell when it looks good. Right? So I agree, that's one of the big issues we currently have with this aesthetics. Yeah. So, but like the current approach then is to, for instance, like the painting generating thingy, is we throw in all imagery of human paintings from the past 5 centuries. We say, this looks nice. Yeah. And then the computer can learn what looks nice. Yeah.
Thank you for the great talk. Is your code open source?
Yeah, I do everything open source.
And like the paintings? The paintings that you show, the Van Goghs and the...
Yeah, so I don't know, that's one cool thing also. I don't know, like this painting has been generated by an algorithm. So who has the copyright? Is it the algorithm? Is it the programmer? Nobody knows. So I think you could pretty easily say that this is, public domain. And the code, most of these code is open source, but usually the problem is that to run, for instance, this thing here, you need like a 2,000 euro machine to run it. It's very powerful. Unless you have like a gamer, you need to think about this, runs on a gamer PC we have in our lab.
Can you explain again what is the origin of the form recognition with the cheetah, the noise picture?
Yeah. So the idea is that the big problems these algorithms have is that they don't have priors. They don't have common knowledge about the world. For instance, that why is it so bad at generating coordinate? I don't know what a coordinate is though. Why is it so bad? Because it hasn't learned that, like, it's probably some kind of gun, no? And that the part of a gun which is here and the other part of the gun which is here, they always fit like this. It has only learned when I see this part, it is a gun. Yeah. So it has lots of these priors, these teeny teeny little things which we think are trivial. So that makes it so hard to explain because we think they're so trivial. When in fact they are not. There's stuff we've learned because we walk around on this world. Yeah.
There is patterns, prototypes to classify. Is it top down or bottom up, or the two together when there is a recognition system functioning?
Usually these type of stuff, this works bottom up, really bottom up. So it looks at very tiny things, like it first starts with lines. And then it learns like a couple of lines together, makes circles and spirals. And a couple of spirals and circles together, we make like a mouth. And a mouth makes a human face. And a human face makes this specific human. And stuff like that. So it's really bottom up, all this stuff works.
I would like to ask you too, there is a lot of a classified system based on similarities.
Yeah.
If you are asking for books or music on Amazon or on Spotify, they choose things similar to your first choice.
Yeah.
And there is never a system which proposes you something which is really different of what you like to see, and maybe it's the thing you would like to see.
Yeah, and you're very right. And that was because that was the best thing we had about 2 or 3 years ago. So when I told you about Spotify, this colleague of mine worked there last year, and he implemented this algorithm which could actually listen to music and tell you whether you would like it or not. Or in the case of Amazon, that would be Amazon has an algorithm which reads the books and then tells you if you would like it or not. Because how these algorithms work now, it's just like you buy this book. I know somebody else who bought this book and he also bought this book. Maybe you will like this book as well. But you will agree that this doesn't work very super well, no? So we're getting there. This is slowly getting there. And like Spotify is one of the first to do it. And I think Amazon, give it 1 year or so, and they will also do it.
Intelligence, Douglas Hofstadter, who wrote Bach, Escher, and Gödel, he said that intelligence is the capacity to distinguish similarities between difference and to find difference between similarities, of course.
Yeah.
So
I know it's a really confusing book.
It's a nice book about system and how to be not to be trapped, how to be free of systems. The beginning of the book is very nice with the logical system of MUE and it's how to escape from a system. That's the freedom of individual.
But are you able to escape your own body? Are you able to leave your body here and walk outside? No. So you're not intelligent.
Yeah, but it's like the Baron of Munchausen. He wants to cross a river, and the trick he found is to take himself by his hair. And jump. So that's poetry.
Yeah.
That's poetry.
I agree. It's poetry, indeed.
The impossible.
I largely disagree with. I didn't read the book completely. Then again, so yeah, I'm very bad at finishing stuff.
Thank you.
Yeah.
It's very interesting, but I have the impression there is something that we miss. So I will first say what I think about art, because you didn't ask what is art actually, and my conviction is art. It's for a big part. Chance by chance, we decide this is good because there was kind of events who happened, and we could decide that something else is art. And here, with this system that you show, we are far enough actually to have really something who can be considered as good art as it is at the moment. So the only, in my opinion, the only big difference who is still there between artificial intelligence and normal intelligence for art is consciousness.
Yep.
And you didn't speak about that because implicitly you were saying when there will be enough intelligence, there will be consciousness. But we are not sure about that. And maybe.
But consciousness is such a troubled term. It's like I know I'm conscient, but are you conscient? You can never convince me that you are. And so I'd rather not use it, not for you, not for these algorithms, because it doesn't make any sense in my head. And do you need to have conscience to create art? I don't know. Like Picasso could never convince me he had conscience, so it cannot be necessary for him to have conscience to create art. This is my point of view, but this is very philosophical.
How do you explain you get these colors?
How do you explain this? This is very cool. I was at a conference in December on the topic of neural networks, and I met this guy, not him personally, but his girlfriend, and this guy does research in London, I think. And what he does is he takes a human lab rat, he gives them LSD, and he puts them in MRI scanners. And he does research in why LSD works the way it works, right? And how does LSD work? It works by, if your neurons communicate with each other, they will start communicating even more when you're under LSD. And so the effect will keep on increasing. So if you think you see a cat somewhere, or not even conscious, your brain figures out this looks like a cat, it will start looking more and more and more like a cat. Yeah. What this does is in fact actually the same, just with an artificial neural network. So when you take an image and you say now it needs to look more like a terrier dog. So what this will do is it will look which of my neurons are firing, and then the ones who are firing fire up even more until this actually looks like a terrier dog. So that's why it looks as colorful as it does, for us humans. Because it works in the same way as LSD works for our brain. But this is my hypothesis. We haven't tested it. Yeah.
So you spoke about this long-term hypothesis about machines that can create media instantly upon after giving them some parameters, which of course, as you say, would change human culture drastically. Imagine the Oscars, and but you also spoke about less trivial uses. And how far-fetched would it be to think about a machine that you can ask to design and create another machine or device that can do this and this?
Yeah, yeah. It's, those are indeed very difficult questions, and I think it will always come down to the same problem: when can you design like a test which will tell you like this is a machine which makes decisions and this is a machine which does not, and it's always the same trouble you will have like in the Turing test, like when you say like humans can make decisions and then you make your test and the humans will be very bad at distinguishing your machine from your actual human. And so what does it mean to make a decision? And you need to define this before you can answer.
To design and fabricate, to produce another machine, a device, not a machine or a device that can you say I want a machine that does this and this, like like the movie. I want a science fiction movie with Donald Trump, blah blah. So you ask them to create some other machine.
Yeah. Okay. So that's what you can do. It's like probably I think the moment we can do this is when we ask machines. Okay, now machine, try to act as human as you can, and that's the moment when the machines will start doing the stuff you explain. And they will just try to imitate us, and by doing that, we will be convinced that they are doing the same stuff we do. I think that will be like the crossing line, but this is future technology, so I don't know for sure. Maybe there's another trick or something they can use. Yeah. But then you could say that the machine is acting, right? That it's not truly making decisions, but how do I know you are not acting? This is always the same problem. Yeah. Yeah, so yeah, philosophically, I take a very functional approach to what makes conscience. Like, as if it acts conscience, it probably is. I don't care about the details.
Maybe one last question? No?
Okay, I'm not sure it's really a question. I just wanted to say something. Because what you showed here is everything is based on picture. Where a kid is small, like 2 years old, toddler or something like that, when you ask him, what is a cat? He will say, cat makes meow. So what I wanted to say is that human is based on experience, not on the theoretical picture.
Yeah.
And what if it would be possible to implement experience for the machine for the other senses than the visualization of something?
Yeah.
What about, smell, sound? Okay, sounds, we have it for Spotify, okay, I get it. But what about touch? What about emotional intelligence, which might be also implemented?
Yeah, chatbot. Yeah, but I understand your question. There are a lot of people thinking that way, and now I think like, I showed you my robot, right? My robot is learning how to walk based on falling. Like, it's tripping, it falls, I learned I shouldn't do that again. And in robotics, a lot of people are convinced that that's the way to go. It's like you need to put a machine, which we would call a robot. So you need to put a robot into this world and have it experience our world in order to become truly intelligent. And it might be the way to go. And I think might be one of the reasons Google is also investing in robots, the way they do. Also the reason why we do mainly images. Oh, this is a parrot. This looks nice. Is that images apparently are easier than sounds. So we are still, like I showed you, we can generate playlists, that we can do, but we cannot generate music yet. That still sounds like noise. Unless you want to like make chords, we can make, how to say, the...
There's a problem doing that.
I'm sorry?
There's a problem on the internet doing that.
Yeah, but they don't make sounds as such. They just put the notes next to each other. They don't make the sounds. And that's one of the goals currently in research, is to get an algorithm who creates sound. So creates the sound wave itself and not just the notes. We're not there yet. And sound is more difficult than images in this sense. Yeah.
So I think that's all for tonight. If you want to ask more questions, you can do it at the bar.
I have cookies.
And take a candy also. So thank you very much. Thank you for your attention. What else is there to say? Yeah, we have the next events, if you want to come in March. They're projected there sometimes. And then, yeah, have a good evening, and thank you all.